So I sort of I conned myself into this tonight when the email came around on Friday saying, whoops, the speaker can't make it. And I just so happened to have done a talk at the RSGB convention a couple of weeks ago, so this is a slightly different, for obvious copyright reasons, this is a slightly different variant on what I said at the RSGB convention. It does presume a little bit of prior knowledge because I spoke a year ago there as well, and so I'll try and make it as interesting as possible. But the other thing we're doing tonight, I couldn't resist the temptation because we're so close to the TV repeater over at Farnham. I couldn't resist the temptation of seeing if we could transmit into that at the same time. So that's actually what's happening. So running off a single PC, we've actually got PowerPoint going to the projector, and then I'm also running a program called vMix on here, which is taking the PowerPoint, it's capturing that desktop, it's got a camera input, and that's producing a mixed output which is going into some other software which is called DATV Express software, which then runs basically it's a digital SDR card in here, which is my DATV transmitter going out to the aerial on the Land Rover, and is accessing HV, and I'm probably running about 5 watts into the Yagi. We were supposed to be receiving it, but I can't receive it, and Frank has pointed out we had the same problem at Farnborough, which we shouldn't have done, so I suspect that my LMB is faulty. So that's the plan, and that's what we're doing, and it all seems to be working. I've got a couple of things to demo later on, so we'll see how it goes. But I noticed we've got some animals, so there's children, animals, demo. It's bound to go wrong, isn't it, somewhere?
So how do you know you're getting in those?
Because I went to the website, the web page. It's being streamed on the internet,
Okay.
and yes, it does seem to be working. Yes, good. So the PC is sort of running PowerPoint, running DATV Express, running vMix, and running Firefox. So let's get on with it quickly. So UK ATV, first an overview of what's happening where on which bands. In the last couple of years, the major thing that's happened is we've got 2 new ATV bands. 146 megahertz is the big one I want to talk about tonight, where we're doing lots of stuff. There's also a new allocation at 71 megahertz, which I'll talk about as well. 70 centimeters, we've always had an allocation on 70 centimeters. People like Bob were on there in the 80s. A lot of people ran AM in the 80s on 70 centimeters, but due to the fact that the band shrunk and a lot of other users popped up and started using it, AM became very unsociable, really. It's 8 megahertz wide. You can't really, you're not good neighbours when you're running that sort of signal. But what's happened over the last couple of years is that we're now running digital, and that's enabled us to go down to 2 megahertz wide. So in the UK band plan at 437, there is actually a segment for digital TV running 2 megahertz wide. And I'll come on and talk a little bit how it's relatively easy to get on there. 23 centimeters or 1.3 gigs is another band where we've traditionally been running FM. There is a lot of analog and a lot of digital activity. There's 34 TV repeaters in the UK, most of which are on 23 SEMS. HV up at Farnham has got an input on 23 SEMS, both analog and digital. 13 centimeters. If you bothered to look at your license when it was reissued about a year ago, you'll see we've lost a massive chunk of 13 SEMS. We lost 40 megahertz, primarily because the MOD is the primary user at 2.3 gigahertz. They are under pressure to hand back spectrum they're not using, and they handed back 2350 to 2390. So there's 40 megahertz in the band that we no longer have access to. That's what called PSSR is, public spectrum something release, public sector spectrum release. But there is still quite a lot of room at 13 SEMS, and there are still repeaters active there. It's a band we'll probably start to use more now we know what's happening. 3.4 gigahertz is the new wonder band. Well, it is if your receiver works. HV up at Farnham runs 3.4 gigs, and it really is very easy to get on there. The band, the amateur band is 10 megahertz wide, the top 6 megahertz of which are nominally used for ATV in 2 megahertz digital channels. And we've got several repeaters around the country. The picture in the top right is a guy up in near Durham who's receiving the local repeater up there. He's just got an LMB and a homemade horn in the loft, and at 20 miles he can receive it. And he uses a Marks and it's actually a dish or a horn made from a Marks and Spencer's cardboard box with tin foil on the inside. If he used a Waitrose box, he'd have probably got 3 dB more. But no, I'll come on and talk about more, because that's how we receive HV. And Bob, you're down in Aldershot, you've just got an LMB on the top of your ladder, on the back of your house, and you receive it. Frank over at Odium, just an LMB, no dish. Over at Basingstoke, I've got one of the same LMBs, but on a Sky Mini dish. It really is very, very easy to receive.
From here, I've done it with the LMB, just holding it outside the door.
That's right, we got it just there, didn't we? And tonight we can't get it on. I think that LMB must be faulty. So, 5.6 gigahertz, there is a repeater input on 5.6 gigs. It's becoming quite useful because of all of these drone downlinks on 5.6 gigs. So we can use that FM video equipment for ATV, and we can do a lot more with it than the drone people could do. And one of the repeaters, GB3KM, has got an input on 5.6 gigs. 10 gigahertz or 3 centimeters has always been an ATV band. We're starting to play digital up there, but FM is very easy. It's always been easier to get on 10 gigahertz than you imagine, mainly because the receivers are just a Sky type LMB, and the transmitter, you can use some relatively simple techniques to get up there. And believe it or not, some guys up north are playing on 24 gigs. In fact, I should update this slide. Rob, M0DTS, has actually seen TV pictures at 134 gigahertz. Only about that far. So that's the band. Where I want to spend some time talking, because this is where a lot of the activity is happening, is on 146. So from October 2 years ago, UK Ofcom gave us access to another 1 megahertz. But they said you can't use more of the same. We don't want you to be using more FM channels, you know, more QPS, no APRS or whatever. We need to see something different. They slapped a maximum ERP limit on of 25 watts. ERP means you've got to include the gain of the aerial. And it's starting to be a killer. And the RSGB put in 500 kilohertz for digital modes, including reduced bandwidth DATV, in the middle of the band plan. There was not enough room, because we've got to get down to 500 kilohertz. We've got to do something very different. And so we couldn't just take what we'd been doing on some of the other bands using DVBS or satellite technology. We kind of had to go and reinvent the wheel. Let me just check we're still... We do appear to be. Good. So, what we've coined this phrase RBTV, for reduced bandwidth TV, and it's normal fast scan. So we're not talking slow scan television. This is all proper moving pictures. and it's below 1 megasymbol or 1 megahertz. And what we've come up with between ourselves is a standard of 330 kilosymbols, which equates to about half a megahertz wide signal. And it's based on the satellite DVB standard, but we've had to make it narrower. So we needed MPEG-4 encoding, whereas previously we'd been using MPEG-2. And also the big problem was satellite receivers don't work. The normal consumer satellite receivers that you buy in Maplin or off eBay are all designed to work on the Sky and Freeview and FreeSat type systems, and the actual specification says they only have to work down to 1.5 megs wide. So they won't work down below. So we had to reinvent the wheel. We had to go and do our own thing down there. As far as transmit goes, well, we had a stroke of fortune because, believe it or not, a Raspberry Pi, even the Model A, has got a hardware MPEG-4 encoder in it. And with a Raspberry Pi camera, and some guys in France, some clever guys in France have come up with some software to run on a standard Pi and to produce an amateur TV signal using the onboard MPEG-4 encoder. And I'll come on and talk a lot more about that because that's a really interesting way, an easy way to get onto amateur television. There are other solutions, a thing called the DATV Express, which is what I'm running here. And that will do a whole variety of solutions from 65 megahertz up to 2.5 gigahertz. Whole range of bandwidths from about 100 kilosymbols right up to 12 megasymbols. And there are also potential futures solutions based on a lot of the SDR products that are coming out. There's a thing called Lime SDR, some of you may have heard of. That one has got a lot of potential. On that board, it's being developed by a team in Guildford. On that board, I think I'm right in saying there's 3 receivers and 3 transmitters and goes up to about 4 gigahertz. Absolutely, if you go and Google Lime SDR, well worthwhile a look. The big thing we found we had to get a grip on is something that all amateurs, of course, should be doing.
Yes.
Is filtering. First of all, for us to operate in that 1 megahertz at 146, there were some pretty tight requirements put on us as far as spectral purity goes. But we found that taking satellite receiver technology and trying to use it without too much filtering on both 70 SEMS and 146 megs really didn't work. I've been doing this a few years now. I went down to Portsdown Hill about 2 weeks ago. Went with somebody else. We were doing some tests with a guy in Worthing. The other guy could receive him. I couldn't. And I knew my receive system was perfectly fine. And what it was, I hadn't got enough filtering before or after the preamp. And at Portsdown Hill, there's a lot of crap. And it really is, we're rediscovering how important filtering is. And you don't have to spend money on it. There are a lot of good designs. We're blowing off the dust off the VHF manuals and rediscovering a lot of the filtering stuff that we all knew that we should be doing anyway. Power amplifiers was another hard area. And this was really following on from what I said at the RSGB convention last year. When you've got a digital signal, it's much wider than a normal sideband signal. Sideband signal, 2.5 kilohertz wide, let's say. These signals are 2 megs wide. They require an awful lot more linearity in the power amplifiers to be able to deliver power. And so what you end up doing is you end up getting what they call spectral regrowth, which is the shoulders you can see on the sides of that signal. Now that is a professional satellite signal, and the shoulders there are about minus 30. Their actual spec is minus 28. it requires incredibly linear PAs to do anything to get it, and we're aiming for much better than that. And what we found is that the only realistic way of delivering the shoulders that we need is by backing off the PAs significantly. For instance, that's on my 146 meg system. I run an 80 watt amplifier. It draws 5 amps at 12 volts, and I get 6 watts out. And why we have to do that is to get those sorts of linearities. You notice the difference between the previous picture where those shoulders had really come up, and where those shoulders come up, that's on 146 megs, that would be into 2 meters. You just wouldn't be able to hear anything. And so we're aiming, the aim is 55 to 60 dB realistically. 40. The one on the left, on the right hand side at the bottom is one of mine. That's about 42 dB. That one there is a 70 watt transistor running at 5 watts with 55 dB. So some really interesting back to basics radio being done to discover quite how to get it right. And of course the other thing is you need good heat sinks and fans to get rid of the heat, and big batteries as well when you're out portable, of course. On receive, I've already said that your Maplin receivers and your eBay receivers won't go below this magic number of 1 megahertz or 1 megasymbol. So the community, the ATV guys, really got together and decided they would design one. And I've got a board here, and that board on the bottom corner is a board that we stock in the BATC shop. Essentially, it's a tuner can on the right hand side from Sharp. In the middle is a USB module which is ready built, and then the board itself has got the power supply components on it. And that is a USB tuner which is specifically designed to go down to these very, very low symbol rates or low bandwidths. And it's not just a receiver, it's also some very good diagnostics tools. And it's really interesting again to look at the digital signals and see what really counts. And in fact, this software has taught us to forget the S-meter. So these are 4 different scenarios. The top one, you'll notice it says RF level or RF power is minus 36, so that's the level. And the digital signal looks great in the constellations. This is quadrature phase shift keying. So you've got 4 dots within the constellation, and you can see that, the signal to noise, or MER as we call it, the modulation error rate, is fairly good, and that's a good decoded signal. That's great. The next one down, the RF level is the same, but it's significantly noisier in the constellation, and this modulation error rate or signal to noise is nowhere near as good. The next one down is even worse, still the same RF level, and the bottom one is so bad that it's not there at all, but the RF level is still the same. And this is all about noise from adjacent channels. It could be noise on the channel, or it could be the transmitter at the other end isn't doing what it should do in terms of putting the dots in the right place in the constellation. And these are all sorts of things that you forget about, or we're having to learn about doing digital properly. Is, the signal meter isn't, an S9 isn't necessarily an S9, is the bottom line. And just to give you an instance, this one, if you look down the bottom there, it's a great strong signal. The dots are really clear, but you will notice how the dots are in the wrong place on the constellation. So the actual error rate, or the signal to noise, is only 7.5 dB. If the dots were in the right place, that would be a full signal. That was taken off some equipment that was actually measured on the bench, just to show, what the difference between having the right digital modulation and the wrong digital modulation. And filters can cause this problem as well. If you tune your filters up incorrectly, you can get what they call group delay, and that will screw up the error rate as well. So these are all things we're having to learn, and realise that, it's a bit back to basics.
So why do people make that tuner then?
Why did we make the tuner?
Well, you didn't make it, Sharp.
Yeah,
Why is it made?
Sharp. What happened was, there's a French guy, F6DZP, who discovered that there is a particular chipset, because all tuners, all set-top boxes are just based around silicon, a chipset. And what this French guy discovered was that there is a certain chipset used by ST, forget that, I forget who makes it, which has got the capability to go down to very, very low symbol rates. So then he found the particular tuners which used that chipset, and there happens to be one, and one only, made by Sharp, one by another company called ATV, and another one by Samsung. And you have to be very careful when you buy these, and of course they're only available from the Far Eastern guys. So we've been buying these and stocking them in the BATC shop so members can buy them directly from us. But it's because they're using a particular chipset which happens to go down low. So that's all the theory behind this new band. So what have we been doing? Well, first thing, 25 watts ERP. Don't forget, the ERP is tough. If you think about 25 watts ERP in a 500 kilohertz bandwidth versus 1 kilowatt ERP, hang on, nobody runs 1 kilowatt. Of course they do. Your Japanese black box will run 100 watts on 2 meters, and you've got a 10 dB toner. That's a kilowatt ERP. It's not difficult these days. Probably most people won't be doing it because the feeder loss on the aerials isn't as good as you think it is. But that, between what we're trying to do on 2 meters and what the sideband guys are doing, there's a 40 dB difference. And that's a big difference. So what we've discovered is that we've really got to go out portable to work the DX. Nobody else has got 146, so it's all into G. I think the Isle of Wight's got it. I'm not sure the Channel Isles have actually. So the Ofcom released the band to us in October 2 years ago. The first QSO that I know about was G4CPE and G0WFT over in Luton on the last day of the year. And currently the record is 183 kilometres, which is Brownclea in Shropshire down to Bell Hill in Dorset, down Blandford Forum. And I actually went up to Shropshire and sat on top of Brownclea. That's a phenomenal sight. It just sits in the middle of in the plain, and you have to engage low gear on the Land Rover to get up this track. It's brilliant, wonderful. Anyway, I worked several stations that day. This was Mike down in Harwell. That was 130 kilometres. You can see the path. Wasn't a clear line of sight path, but I did get decodes from him. If you look at the constellation, it's not the projector. It actually was that bad. You can see that red bar meter on the side. There was errors starting to creep in on the signal, but I did get a decode from him, and that was at 130 kilometres, but over an obstructed path. Next one was, there was a group of guys went down to a site near Shaftesbury. G8NSY was one of them. Slightly obstructed path, better constellation. You can see the four digits forming. Why is he looking at his watch? Well, the reason why he's looking at his watch is we've always used 2 meters for talkback on amateur television, 144/750. Even when you're only running 6 watts on 146, you can't hear anything on 144/750. So we do okay, I'll transmit for 5 minutes. So that's Brian down on I think it's Wyn Green is the site. From the same site Sean, G8VPG, notice the difference in signal strength and how clear his constellations is. He's not running that different a setup, but I think what happened is a QSB just came up at the right moment. I happened to managed to do the screen grab, but very good signal from him, very strong. So that, at the point when we did it on the Saturday morning, was the new world record for 146 megs TV. Unfortunately for Sean, Dave G8 GKQ came along about 15 minutes later. He said he was famous for 15 minutes. Dave was down near Bell Hill, which is Blandford. As you can see, yeah, marginal signal, but certainly worked. Slightly obstructed path, but pretty good. And what's video look like at 146 or at these bit rates? This is just, we're called the British Amateur Television Transmitting Club, because we don't do television really. We're much more interested in the RFE bits than the camera work, as you will see. There's no audio on it. So, you know, highly professional station. He smiles in a minute. He knows it's. But that's a Raspberry Pi. He's using a Raspberry Pi camera, 500 kilohertz. Yeah, and then that's the site he was on. As you can see, it's pretty good going out to the north. And he's just using the 5-element Yagi on too. And to be fair, we are all sticking to the 25 watts ERP plus or minus a tiddly bit, but you know, we're all running 5 or 6 watts into Yagis, which about 10 or 12 dB with a bit of feed loss. So we're plus or minus, you know, a dB or so, and we are playing it by the rules. Right, let me just check to see if we're still. Yeah, we seem to be. Okay. Oops. So that was 146 megahertz, which is the new band, and I guess that's where the fun is, really. You know, there's a challenge there to do it because it's harder. 70 SEMS is easier, and of course we can either run the wide 2 megahertz signals there, or we can also do, there's no reason why we can't reduce the bandwidth down on 70 SEMS as well. And of course there's no ERP limit, and it's a lot easier to get aerial gain on 70 SEMS. For some reason or other, we just prefer where it's hard, I think. F9ZG, a lot of the French haven't got 146, but they're very, very active on 70 centimeters, and they do tests regularly, most days over 250 kilometers. And what they've also found, believe it or not, is that, you know, reducing the bandwidth makes 3 dB every time you halve the bandwidth, and you know they're achieving some pretty good stuff. One of the interesting things is a guy up on the edge of the North Yorkshire moors. And 70 SEMS is a shared band. We have a primary user there, and some of you may know that the primary user has got a large installation on the North Yorkshire moors that looks something like that. And he's worked out that he could slot himself into between one of the primary user peaks on 70 SEMS with the reduced bandwidth stuff. We're now playing around with 10 gigahertz as well because, well, it was one of those, hang on a minute, moments. We've got 437, we're actually using 437 to transmit into the repeater here. So that's easy. Over here, I've got a 10 gig, well I haven't, but I'm pretending, got a 10 gigs narrowband system, which I've had for many years, which I run 70 SEMS as the IF. So with this, a little bit of switchery and doofering, we managed to get, or two of us have managed to get on to 10 gigahertz running this narrowband stuff. And we've done about 100 kilometers, 93 kilometers on 10 gigs video, which is good fun. 71 megahertz. 71 megahertz has been released to us for about a year. You may or may not be aware. an extra 1 megahertz. And again, the RHEB has said, yep, you can have 500 kilohertz in the middle to play. Where 146 was an NOV, you can go onto the RHGB website tonight, and if you're it's not called Class A anymore, I was going to say a full license, that'll do. If you're a full licensee, you can apply for an NOV for 146 megs, and you'll get it by return. 71 megs is slightly different in so much as that is a special permit, special experimental permit. 4 stations I know of have applied for those. It's going to be very interesting to see what they can do on 71. You initially think, wow, you could do great things, but all of the propagation at 50 and 70 tends to be via sporadic E or tropo. And you get a lot of phase changes and multipathing in those propagation modes. And one of the things we've discovered is that QPSK, which is what we're using, which is a single carrier system, doesn't like too much phase change, because what happens is the dots, if you remember the dots in the constellation, they rotate round or change with phase changes. So it's going to be interesting to see what 70 megs does. But my gut feel is that it's not going to do quite what, people have watched, everybody says Crystal Palace was watched in Australia. Yes, it was watched on AM, running a lot of power, and AM is much more resilient to these types of propagation modes. So it's going to be really interesting, but there is an opportunity there if anybody's interested in playing. Have a go on 71 megahertz. There will be a local signal for you from 4 marks. Mike, GAWS is on. So we'll see what's going to happen there. It could be interesting. We discovered that ATVs tend to do this sort of stuff because that's what we do, and we had to try and do something to get us out and about a bit more. So we do organise activity days to go out portable. And it seems to have worked. There's an IARU TV contest every year. Unfortunately, in 2015, we put in 0 entries from the UK. It was a bit of a low spot. But this year, through drumming up activity, we actually managed to get 15 entries into it this year. So, hopefully we turn the corner. But we are trying to get out and about more. So we're organising specific days when we go out and do interesting stuff. What's next? As I say, this was for the RSGB convention, and there were a couple of guys there who we were trying to influence and show that we were doing interesting stuff. And the next thing is we're playing around with the other satellite standard, which is called DVB-S2. Now, DVB-S2 was brought into the commercial world with the introduction of high definition, because high definition takes much more bits, bigger bit rates, and therefore bigger bandwidth than standard definition does. And what S2 does, it gives you more bits per hertz, so more signal for a given bandwidth. And it means they can get one HD channel approximately into the same as they could an SD channel. So, the business case was there to say we can now run HD, whereas we used to be able to run SD. So all of your HD satellite boxes are now what they call DVB-S2, that's the modulation. And the benefit for us is not so much that we can run more bandwidth, although some of our guys down in Bristol are playing with HD. Because once you get to this point, you can start to do high definition. Everybody's got a high definition camcorder. So there are guys down in Bristol across town playing with HD. The other nice thing about it is that it operates closer to what they call the Shannon limit. And it gives, in theory, gives 2 to 3 dB over DVB-S. And that's significant when you remember we're limited to 25 watts ERP. So if we can gain 2 or 3 dB somewhere else in the system, we'll take it. And this graph just shows, if you look, the blue line, DVB-S, we run down in the bottom, which is the QPSK region, which is down the bottom end of this line. So for a given carrier to noise, we can carry that many symbols. So the carrier to noise on the bottom of the blue line is, on the last dot, is around about 2.5 to 3 for a given bit rate. The DVB-S2 line comes right down the bottom here. So in theory, for the same bit rate, we can gain 2 or 3 dB over the system. And literally in the last month, we've been out on Portsdown Hill, myself and GAGKQ, doing these tests over a 40-kilometre path down to the Charles G4GUO in Worthing, and we have proven that, you know, it looks like DVB-S2 could give us that 2 dB. So we're still experimenting with it. We're having fun. There's a mode in S2 which is called pilot symbols. It's supposed to help the receiver understand the signal it's receiving better. It sends information, but it doesn't seem to make any difference. So we had our first QSO on DVB-S2 at Portsdown Hill, and here's the interesting thing: what it looks like. If you look at the constellation in the top corner, you've now got 8 bits rather than 4 bits. And if you go down, that's actually 16, and that you can't actually see it, but it is 32. So we've received QPSK, 8 PSK, 16 APSK, and 32 APSK. This is more just for information to show that, you know, we are pushing forward. We're not, you know, there's always something new to play with, I think is the message here. I'm talking of something new to play with. The other thing that's happening in amateur television, which is really interesting, is there is a geostationary satellite going up in probably this time next year. The launch was due to be Q2 next year, but because of the SpaceX catastrophes, it's now been pushed back. But Esaosat, which is the Qatar National Satellite Organization, is launching a couple of satellites, and they're direct-to-home satellites for the Middle East, so they're like Sky satellites for the Middle East. One of the crown princes in Qatar is also a keen amateur radio enthusiast. Yeah, and so when they specified one of the satellites, there is 2 transponders being put aside which will be used purely for amateur radio purposes. Now, the reason why this is interesting is this will be the first ever geostationary satellite, so no more of this waving your arrow antenna to receive them. These will be fixed at 26 degrees east, which in our parlance really is right next to sky. I mean, it's 2.5 degrees east of sky, and you will be able to receive them probably on a sky type size dish, so the neighbours will never know. There are two transponders. One is going to be for narrowband, so it's 2.3 gigahertz up, so 13 centimeters up, and 10 gigahertz down. But don't panic, 2.3 is relatively easy to transmit, and 10 gigahertz is even easier because you just use a satellite LNB on a Sky mini dish into something like an SDR or even an RTL dongle would get you receiving the narrowband segment. The bit that we're really excited about is there is also, the second one is a wideband transponder, which is going to be 8 megahertz wide, bent pipe. No spot beams, so it covers a third of the Earth. Note, it doesn't cover North America. And the 8 megahertz bent pipe is dedicated to TV use, because the other transponder is for narrowband use. All sorts of challenges and opportunities. How do you organise yourself on this? Isn't it open to piracy? Yes, it probably is. How do you know what the signal is? Because there are so many different variations that you can have in an amateur television signal. There's a whole load of challenges. We've realised that coordination is going to be essential if we're going to make the best of it. And we're building, BATC is building a web-based monitoring facility which will have a spectrum display and a chat board whereby somebody can say, right, I'm on channel 7, I'm running a half FEC at 1024 symbol rate type thing, so coordination. But you know, that's going to be so cool, and you will be able to receive it on a Sky type dish. So it's a year away. They're saying Q3 at the moment, Q3, Q4. As I say, the space is very variable, and it's on a SpaceX rocket, so hopefully. But watch this space. That's going to be interesting. So you know, you're probably going, well, how do I? This is all interesting stuff, but so we're looking to put together a getting started project, which we will have a beautiful publication documenting it all, won't we, Frank?
Yeah, of course.
Good man. And what we're thinking is that the transmit will be based around the Raspberry Pi. This is a Model A. This is an original Pi, and this works. I can show you this one working. This isn't the final project that we would do now, but there's a board inside here. So the Raspberry Pi runs some software which is open source in this particular instance, into a board which sits on top of the Pi, which takes the transport stream or the I and Q signals out of the Pi through the GPIO, and has got a modulator on here and a local oscillator. So that works. I started on 146 with that. Because there's no filtering, it also works on 70 centimetres. So it's great for doing a demo. But that's the type of thing we're thinking of. It will probably be best to run a Model 3, but do you know what? They're only 30 quid. You know, a Pi 3 is 30 quid, and that gives you all of the MPEG encoding. Camera, I forget how much the camera is, over 15 quid now. And what we're doing is we're specifying it so it will work on these low symbol rates, so the lower stuff I've been talking about, also up at the wider 2 megasymbols rate. And the reason for doing that is you will be able to receive it on a standard consumer set-top box. So it would have to be an HD set-top box because you need this S2 thing. No, because it's MPEG 4. Oh, it's very complicated. And only the HD boxes can decode MPEG 4. So, but we're doing 2 megasymbols plus the reduced bandwidth stuff. So it could be received on a standard set-top box. But you would need, if you wanted to get into the narrowband stuff, you also need to do the reduced bandwidth TV tuner, the USB tuner. But that's a relatively low tech constructional project. And our aim is to enable to come to guys like you and say, if you built this, this and this, and you stick it into your white stick collinear that you've already got on the roof, you would be able to work across town. And we believe if we can do that, and if we can make it simple enough, and Frank documents it lovingly and it really looks nice and simple, you know, we can get you guys to do that. And we're even thinking something, you know, we would try and encourage clubs to adopt it as a club project, because there'll be a bit of construction, there'll be a bit of software, there'll be a bit of bolting bits together. And it really is, you know, going to be an easy way to get into it. And so the transmit would look something like this. So that's the original Pi. That would run the French software, which is got proper Raspberry Pi distribution, so you don't have to remember to load what onto what. It does automatic installation. We then need a hardware QPSK modulator. That's the original one there, which we're currently thinking about how we do that properly. There'll be a local oscillator. Local oscillators are easy these days. It's unbelievable. There's a chip called the ADF3451, which will go from 30 megahertz to 4.4 gigahertz. And you can control it with an Arduino or a PIC. You know, it solved all the local oscillator problems you had when you were trying to do anything that's not in a Yaesu black box. Of course, you'll build a filter and then a power amp. But some of the guys, I think it was in Luton, they did work cross town just on the basic modulator board. So basically 10 milliwatts, you know, a couple of miles distance, they worked like that. For receive, as I say, you could use a set-top box. If you want to go down the hard way, preamp, filter, USB tuner and PC. There is a new tuner around which covers 140 to 2.4 gigahertz. What that means is we won't even have to include the L-band up converters, which we do at the moment because the frequency range will be wide enough. So all of the bits are there, we just need to pull them in and glue them all together. And that's pretty much it.